Okay, this is the last video for the quadratics review. I'm covering numbers 7 and 8. So number 7, it says for each equation, write a statement about the minimum or maximum and where that occurs. Now, on the last day, we talked about minimum and maximum, and we talked about that in relation to like vertical motion. But this applies to any parabola. The minimum or maximum is asking about the vertex. And so the vertex, whether it's a minimum or maximum, depends on whether the parabola is opening up or opening down. So in the last question, number 6, we determined whether the parabolas were opening up or down. So now for this one, to find whether it's a minimum or maximum, you want to do that first. And then you can determine whether you have a minimum or maximum in your vertex. And then where that occurs is the x value of the vertex. Okay, so where that maximum occurs is the x value, and the actual minimum or maximum value is the y value of the vertex. Okay, so really all they're asking here is to find the vertex and just say whether it's a maximum or a minimum. All right, so for part A, first of all, I'm going to say, is that opening up or opening down? Well, A is negative, so therefore it's opening down. I find this always helps me to draw a picture. I don't have to have the correct parabola, just a parabola that's facing down. So since this parabola is going down, I'm looking for the vertex, right? So I want to identify if that's a maximum or a minimum. So since it's going down, I see that that point is a maximum. Okay, so that's half the points right there, is just determining is it a maximum or minimum. So once I've determined that, now I just find the vertex. Finding the vertex is going to be different based on what kind of equation, what kind of form I've given. So in part A, we're given vertex form, so that's really easy to find the vertex. All we have to do is HK. So our H is 3, and remember it's the opposite sign that you see for the X, and then the K is the same sign that you see. So our vertex is 3, 8. So what that means is I have a maximum of 8. That is my maximum value. So remember, that's the y value of the vertex. When x equals 3. That's what they mean by writing a statement. So you have a maximum of 8 when x equals 3. So now for part B, again, we want to find if it's a maximum or minimum, so that is determined by whether we're going up or going down. So A is positive, so that means my parabola in B is going up. And if you look at the vertex, that's at the bottom. So if we're opening up, we have a minimum value. Now, if you see, part B is actually in vertex form, because that x right there in parentheses, there's nothing subtracting from it, so that means that the x value of the vertex is just going to be 0, and then the y value is that k, which is negative 1. So that is my vertex, so that means that I have a minimum of the y value, which is negative 1. When does that happen? When x equals 0. So that is my statement. Okay, for the last part of the review, we're going to be graphing the parabolas. And we're going to be including 5 points, except for the last one, part C, we're going to do 3 points. I've given you one of each type of form. We have standard for part A. Then we have factored in part B. And then we have vertex in part C. Okay, so for standard, remember standard form doesn't tell you anything in the equation. So we're going to have to start off with another formula. Remember, that's the axis of symmetry. Remember, the axis of symmetry equation is negative b over 2a. So for this one, our b is negative 4. So that would be negative of negative 4 over 2 times our a is 2. So then that gives me that would be a positive 4 over 4, which is 1. So that means my axis of symmetry, remember, graph as you go. So my axis of symmetry happens at x equals 1. Now, remember, the axis of symmetry and the vertex go together. So that means that once I've found one, I can find the other. So axis of symmetry tells me the x part of the vertex. So now to find the vertex, all you have to do is plug in that 1 back into the equation. So my equation is 2x, so that's 1 squared, minus 4 times 1 minus 6, which is 2 minus 4 minus 6, which is negative 2 minus 6, which is negative 8. So my vertex is, I plugged in 1, I got out negative 8. So now let's plot that point. Okay, now that I have the vertex, all I'm really trying to find are other points that are on this graph. So I've told you that 0 is always a pretty good one to try. So we're going to go ahead and try x equals 0. Again, it really doesn't matter, but we like to stay pretty close. So since I have 1 already, I'm going to draw numbers close to 1. So trying 0 will lead me to get, actually, if I plug in 0, that's going to cross out, that's going to cross out, leaving me with negative 6. So when x equals 0, y just equals negative 6. So that's the y-intercept. All right, so now we're going to plot that point, 0, negative 6 is here. And now we can use the symmetry. That's 1 point away from the x's symmetry, so now I have another point. And so now I need one more point. I won't try 2 because I already have that point with symmetry. So I'm going to try 3. Okay, so try x equals 3. Since I don't have any weird fractions going on with this graph, with this equation, then 3 should be safe. So I'm going to plug in 3. You get 2 times 3 squared minus 4 times 3 minus 6, which gives me 2 times 3 squared. 3 squared is 9. 9 times 2 is 18, minus 12 minus 6. So that was actually, is that 0? Let's see. Yeah, that's right. So 18 minus 12 is 6. 6 minus 0. 6 minus 6 is 0. Yeah, okay. So that gives me 3 comma 0, which if you notice is actually an x-intercept. Okay, so let's plot that point at 3, 0. And so that's 2 points away from the axis symmetry, so go 2 points away again, and now you have a very skinny parabola. All right, so then moving along to part B. Okay, part B is in factored form. So factored form tells us the x-intercepts. Remember when you're in parentheses, it's the opposite sign. So the x-intercepts are positive 2, 0 and negative 6, 0. Remember to graph as you go. So I'm going to plot positive 2, 0 and negative 6, 0 on my graph. Now I see those symmetrical points, so I know my axis symmetry is in the middle. So you could average those two together or look in the middle and you get at x equals negative 2. So I know that my axis of symmetry is at x equals negative 2, and I get the vertex from the axis of symmetry. So to find the vertex, we're going to plug in negative 2 in for my x value and evaluate. So we get negative 1/2 times negative 4 times 4. I always multiply my big numbers first. So 4 times negative 4 is negative 16. And negative 16 times a negative half, you get positive 8. So my vertex, I plugged in negative 2, and I got out 8. So now let's plot that point, negative 2, 8, and that should be my vertex. Now to find other values, notice that I do have a fraction of 1/2. So, and notice that from my axis of symmetry to these x-intercepts, I have 4 spaces. So what I'm going to do is I'm going to try to keep even spaces. So you can go in between and maybe do 0, because that's right in between the axis symmetry and the point. Or you can go out a little further, but I'm going to go with 0. If you plug in 0, then you would get negative 1/2 times 0 minus 2 times 0 plus 6. So that's going to be negative 1/2 times negative 2 times 6. Negative 1/2 and negative 2 are going to completely cancel and get positive 6. So that's the point 0, 6, which is right here. That's 2 points away from the axis of symmetry, 2 points in the other direction, and you have your parabola. Okay, last example is part C. Part C, notice, is in vertex form. So vertex is HK. So my H is that it's actually going to be negative 3. But notice that I have nothing sitting here for my K. And that's exactly right. The k here is actually 0. So my vertex is going to be -3. There's nothing added on the end, so that's -3, 0. So I'm going to go ahead and graph -3, 0. And that's my vertex, as well as, if you notice, my x-intercept. This is an example where I only have one x-intercept. So, and also, so I have one x-intercept, which is my vertex, and then that's where my axis of symmetry is going to be. All right, so now I need some other points. Again, I naturally like to try 0. So if we plug in 0, we're going to get 1/3 times 0 plus 3 squared. And so 0 plus 3 is 3. 3 squared is 9. So you get 1/3 of 9, which is 3. So I have the point 0, 3, which is my y-intercept. So that goes here. That's 3 away from the axis of symmetry. So, sorry, my axis of symmetry is a little crooked. Oh, sorry guys, I'm not paying attention here. There we go. So it's 3 away from the axis of symmetry, so 3 more away, and you have this. I told you only 3 points for this graph, so draw the problem. Okay, I hope this was helpful. If you need any more help, please email me or come and see me on Wednesday or Thursday.